Hello everyone, my name is Mikhail Tuzovsky and today I am going to show you our PVT model at benchtools.com. PVT is the basis for any petroleum engineering calculations. In other words, everything starts with a fluid PVT model. Let's try and see how it works on BenchTools. Here is our main page, and here is our PVT tool right here. Let's open it and look at it. Here it is. First of all, notice that we have a black oil model opened and ready to use as a default. All inputs are populated, graphs uploaded, and outputs are calculated as well. I think the best way to show a demo is actually to solve some kind of a problem. Let me just go back to the presentation. And here, let's try to solve this one. We have this great book on PVT by William McCain, and the exercise we are going to solve today is 11.2. So let me read it for you. You recently completed a well producing 39 API oil and 0.95 specific gravity gas at 598 GOR. Producing gas oil ratio has remained constant, so you believe reservoir pressure is above the bubble point pressure of the reservoir. Estimate bubble point pressure given that reservoir temperature is 250 Fahrenheit. To solve this problem, let's go back to a PVT tool and start. First thing in the workflow are inputs. Let's name our model as an example. We put demo as a brief. Let's share the model with the public. We choose oil as a fluid type. We'll switch the units. Next, we need to answer this question. Which do you know best, bubble point or solution gas ratio? In our case, we know that producing GOR is constant and reservoir pressure is above bubble point pressure. This means that GOR is equals to solution gas ratio. So we know RSB and we want to find bubble point. Let's continue with inputs. So here we will put 5.9, here it's 39, here it's 9.5, we will not change the water. For reservoir pressure, we don't have it given in the problem, but we know that it's higher than bubble point pressure. So let's assume for now 3000 psi. And reservoir pressure is 250. Temperature, sorry, is 250. Alright, all inputs are ready. Now we can just click this calculate button and see what's going to happen. As you can see, all the properties are generated. Let's check the bubble point pressure. Looks like it's 2057. And notice that our guess on reservoir pressure was actually okay too, as the bubble point is lower than reservoir pressure. As easy as that, I think we're done with our problem. And it was very quick and minimum learning curve required. So we have some more time left to show you some more things here. First is the output table. Here we have oil properties as density, bubble point, B sub O, viscosity, and oil compressibility at the reservoir temperature and pressure. Also, on the left we have 5 nice plots with the properties of oil. And clearly you can see the bubble point pressure on each of these plots. If you like, you can export the image or even download the data as an Excel. Of course, engineers love to have a table. And here in the bottom, we have also a table of properties starting from reservoir pressure to the standard conditions through bubble point, which is highlighted here. You can export the table to a format you like as well. Finally, let's save our results. We have a couple of options for this. First, we can save it to a file, and the text file is generated. You can save it on your computer and use later. Next is just to save it to the cloud. As easy as that. Now you save it to the cloud. Here it is. In this case, we also save it to a public cloud. As you can see, it's right here. And now, what you can do is to share this link to the colleagues, classmates, and friends. And finally, we can get the results of our work as a PDF report, right here. The report is generating. Here it is, with all parameters you just input, calculation details, results as a table and as a plots. So this was a quick demo for PVT model at benchtools.com. Thank you for watching. I hope you learned something and enjoyed it. Have a good day. Bye now.